Welcome to part 2 of the BinMat R tutorial. So this one will look at how you read in data that has grouping information. So let's just go right back to where we left off in the last one. And I still wanted to add in how to actually write your consolidated matrix to a file. I forgot to add that in the last video. But let's say you want your consolidated matrix, you want to save this as an Excel file. All you have to do is use the write.csv function, and you will pass it in your argument, your first argument, which is your consolidated matrix. And then you just need the address of where you want it to go. So I will just put it on the desktop here. Let's just call it consolidated cons, right? You run that line, and if you check the desktop, it should save. Here it is. Here you go. So that's just a quick way of writing out results. But to get back to the main issue here, let's say you have this. So you've consolidated, and then you added in the second column, you add in your grouping information. So previously this isn't there, you add this in, and it has to be in the second column. So everything else is exactly the same. So reading this in, we do exactly what we did before. I'll just call this ISSR groups, and the same read.csv, file.choose, and it's this file. If I have a look at it, here it is. So the first function that you can use is, well, you can do your upgma clustering tree. So you feed it in the exact same things as you did before, except this time it's issr.groups, and you have to now set this fromFile as true, because you've just read this in as is, and you run that, and here's your whole clustering tree. What you can do now is start preparing to make a non-metric multi-dimensional scaling plot. So to do that, you just use the function called scree, and you pass it in your data set. Just check always what the defaults are set as, but I'm just going to plot for the first 3 dimensions. You'll see you'll see a red dotted line at a stress value of 15%, and you want to use a dimension number that is equal to or less than that. So here you can see that using 2 dimensions would be fine. And then you run a shepard. You create a shepard plot. So using the shepard function, you put in ISSR groups again, and this will show you how well the data fits using 2 dimensions is set as the default. K is equal to 2. So when your dimension number is 2, this is how the data fits, and you'd want your R squared value to be as high as possible. If I plot this scree again with 4, you'll see it just keeps decreasing. But anyway, if I run the shepard plot at a default value of 2, let me run it at a dimension 3 dimensions, and you'll see that the R squared value will increase, but it's better to use the lowest dimension value you can. So 2 is definitely the way to go then. And then once you have confirmed that 2 dimensions is suitable, then you can create your nmds plot. So this function requires 2 arguments that you need to prepare first, and that's a color argument and shapes. So the color of your groups. So what color do you want the dots to be for each group that you are needing to show, and then the shapes to go with it. So let's just create an object called colors like this, and I'm going to wait. Let's just check um, how many groups did we have? One, two. We have 3 groups. Okay. So we're going to say, let's say we have red, blue, and green. And we'll create a shapes object. And if you look up PCH numbers for R, you'll see like 16 is the dots, and you have all kinds of diamonds and squares and all of those. So I'll just use dots for all 3. Then you can run your nmds function. So I'll pass it in ISSR groups. I'll set colors to be that object we just created, and shapes to be that object. And you can have a look at what the other possible parameters could be, but when I plot this, it will output the appropriate plot. If you want labels, for example, you just say labs equals t, and it will put the names next to each dot. If you start typing in the function, look, you can set the k value. It's the default of 2, but you can change, and you can change the point size as well. So let's say you want larger dots. You'll just adjust point size to, you can go crazy. But that is all the functions. I just want to see no names. Okay. Yes, I remember. In when you are choosing colors and you just want to confirm how many groups you have, there is a function called group.names that I forgot about. And you pass in your data frame there, and yeah, here it'll give you an output of what names are what your group names are. So then you can easily see, oh, okay, I need 3 colors and 3 shapes. That is the rundown of all the basic functions. But I would advise you to have a look at, go to packages, click on BinMat, and everything has been documented. So if you want to get more information about, let's say, the consolidate function, you just have a look at the description, how you use it, what the arguments are, and you can see a little example. And then if you look at the description file, you'll see there's quite a lot of text here, but have a look. There's a link to the Shiny app program here. If you copy and paste this link into Google, it will bring up this graphical user interface version of the program, and you can upload your files here, and you can do all the same functions that I just showed you in the package, but it's all buttons and tabs and things, which makes it a lot easier. And there's a help file here. You just click on the question mark, and you can see examples, what it all means, which packages are used, how the error rates are calculated. Yeah, please go through this. It'll be really useful. And also, if you want to look at the CRAN page, have a look at the vignette down here. This is also an explanation of everything, all the functions that are available, also methods, and a worked example of the exact same data set that I just worked through in this video, showing you all the output. So work through that as well. So let's say, for example, I want to upload um, the reps. You just upload it here. You can do the check. It will say none, no unwanted characters found. You can consolidate. It'll tell you when it's done, and then you can download that matrix. Have a look. There you go. Here's the consolidated matrix. And then you can get your summary info. You can get your error rates. You can download. You can remove samples. You can create the clustering tree. You need to, in order to do this, though, you need to upload the already consolidated file. You can set the bootstrap values. You can create an nmds plot for your group data. So let's say I now select this one. It will bring up a table automatically with your groups, and then you can just select the colors you want and the point shapes, and then you can plot that. So leave it at binary. For example, let's just say I want this to be black. I want this one to be red, and this one, let's just say green. Let's leave them as circles. We leave it at 2 dimensions, and then we can plot. Here you can include, you can increase point size. Just click plot again, and it will increase them. You can download the Jacquard distance matrix. You can show sample labels. You can download this plot as an SVG file. And just as I showed you with the scree plot and the shepard plot, you can also do that here. So you can plot your scree and your shepard, and you can download them. And here's a tab for filtering as well. Like, you can remember when I said you can remove samples. You can do that here as well. You can check. So let's say 10. It will tell you how many it removed, and then you can download the new reduced set, or you can download the removed samples. So play around with all of this. There's a lot you can do, and don't forget to click on the help files and read the vignette. On this server, because it's a free plan, there is a limit to the memory that is allocated to processing. So if you have a really large file, this online server might time out. In such a case, you can run this in R itself. So what you need to do here is you need to run a line of code. You first need to install the Shiny package. So you do the same thing, you go install Shiny. Once you've done that, you just run a line of code like this. You say Shiny double colon. You run run GitHub. It's a function within the Shiny package, and then in quotation marks you type out BinMat, then comma, and then quotation marks again, and it's CJM, all capitals, a little v and a large S, like this, and you run that, and it will open up that Shiny app via your R. like this, which will allow you to upload larger data files. Um, it looks exactly the same as the online version. So if it does time out, then just opt for this option. So I'll put all this code in the video description, and also the links to the Shiny app and the GitHub repository. I hope that this has helped. If there are any questions, please email me, and happy experimenting. All right, good luck.